Hey students, we're going to talk about streamlining the setup, which is the third step of single minute exchange of dies. Okay, so there are lots of ideas that go with this, but some examples are when you are using a bolt, it is only the last turn of the screw that tightens, and it was the first turn of the screw that loosened it. All of the others are waste. Now that's not exactly true, right? Because we know that all of those others may be necessary to achieve enough strength in the screw to be able to withstand the loads. However, when you're thinking about loosening and tightening something, it takes a whole lot of time to do loosening and tightening of all those threads. Threaded fasteners are a very slow way to put things together generally. So if you can figure out a way to both achieve the strength that you need, but also only do the last thread when tightening and the first thread when loosening, that would be great. Okay, so things you can do. One is to make the screw the right length. You have to be a little careful with this because there are standards on how many threads protrude out the end of the screw, but making it the minimum acceptable length where it is still a strong screw. One is to use pear-shaped holes or washers. And so lots of times you can have washers and holes that look like this, so that the head of the screw fits through. You move it over into the slot on the side and then fasten it. This allows you to have the screw length already set beforehand and already screwed in for 14 of those threads, and you only have to move it over and tighten the 15th. Other ways that you can do that are to have these split thread nuts. So there are several styles of these. This one, the nut twists so that there's a slot. You can slide it right onto the side of the bolt, and then you can spin the top half around, and it makes a complete nut to be able to screw it on. There are also quick release nuts. So on a quick release nut, when it is angled, it will grab. Well, it depends on the style of nut. This one looks like when it's angled, it will slide up and down the screw, and then when straight up and down is when it will lock. I have a vise for woodworking that is somewhat the opposite of this. It is that it locks when it's angled, but it's really nice for that vise. Maybe I'll include a short video of that. Okay, you can also use U-slots in the edges of parts. So instead of putting in a circle and a hole, that's what they call that, a hole on the edge of your die so that you have to, or your fixture, so that you have to put a bolt in there and then screw a nut on from the bottom. If it just has a U, then you can have the bolts already to the right length in place and just slide the fixture up against the U. Now there are some challenges with that as well. The hole has a better chance of positioning the fixture accurately. So if you're using that hole for positioning, that won't work very well. And then you can also use U-shaped washers where you don't have to unscrew. If you need to shim this to make it be further away for some reason, you don't have to unscrew the nut and put the washers on. You can just slide the washers into place. There are lots of other ways that you can streamline all the aspects of a setup operation. One is having a single motion device. So instead of having something that you're screwing together, just have a cam lock. So in the jigs talk, we'll talk about that a little bit. Just a single handle, single motion, and it's locked. You can also use vacuum and magnetism because they're just a switch and they're on and at full grip. You have to be really careful with them though, because now there are requirements on cleanliness and flatness of your part that you may not have had before. Oh, and magnetism as well. You can have tapered slots if you need precise positioning. So instead of just having a U slot, you can have it taper. In that way it will move onto the shaft and position at the right location. And then also having alignment guides on the table is a really good way to do things. Having items that are down there that allow you to locate well to start with. One of the things that he works with continually is working to eliminate test runs. So if you have to set the fixture up and then machine a part and then go measure the part and then tweak the adjustment and machine and measure and tweak and machine and measure and tweak, that's very expensive. The machine is down for a long time. It's a huge burden on the inspection as well. And so anything that you can do to make it so that it plugs into the right place and is ready to go is good. So I mean, there are lots of things that have come out of these ideas, but one is there's a set of fixtures that have pins on the bottom of them, and those pins fit in high precision holes, and so the fixture table is a set of high precision holes, and you can take the fixtures, you make them with these pinned fixture plates on the bottom. They just fit into the right place. And then there isn't any tuning. There also isn't any work finding your part. You know exactly where it's going to be. Using V-blocks on the part and fixture for alignment is another good way to align cylindrical parts. So I don't know if you have ever put a vise in place on a machine tool. It is an exasperating and slow process if you don't have any optimization done for it. So right here on the side there are these two slots, so they followed the idea of having U slots instead of having holes. Partly that's because you can't get to the nut when it's in the table. It's down here inside the table. So what you do is you put the vise on, and then you put bolts in here. There are little tabs on the bottom of the vise that help to pre-align it to sort of the right position. And then once it's in sort of the right position, you take a dial indicator and put it in the spindle, and you run it across the face of the vise, and you see how much the vise is at an angle. And then you take the side of the vise that's at an angle and you tap a little bit with a hammer, a rubber mallet, and then you measure again. Tap, measure, tap, measure. Okay, well now you got it to where that's straight, but you still have to tighten the bolts. And when you tighten the bolts, it will move the vise some. So what you usually do is, before you tighten the bolts, you actually don't measure it to be flat. You measure it to be a few thousandths or 10 thousandths out, so that when you do tighten it, it will adjust it the right direction. But often you tighten it part way, and then you measure again to see where it is, and you tap it, and you measure, and you tap it, and then you tighten all the way, and then you measure at the end to see if you got it, and sometimes you did, and sometimes you didn't, and you have to loosen, and you have to repeat. So this can be a pretty long process. It's at least 10 minutes for somebody who's really good at it, and for somebody who's not experienced at it, it can be a half hour or an hour kind of long process. And so on any vise like this, having holes in the table so that you could just put it in the right place and automatically know that it's in the right place would be a huge, huge advantage. The last thing I want to talk about with this before we go to a video is the least common multiple system. So in the least common multiple system, what you do is find ways to use a single system that will serve multiple purposes. And so in this example, Shingo needed to have two different ways of making these grinding wheels be at different distances apart from each other. And so they needed to be at this distance that's shown in the upper picture and then also in the lower picture. And so the solution was to make this stepped interface coupling. And so when you needed the small ones, the steps are interleaved. And then when you need to make the big ones, the steps are rotated a little bit so that they are further apart, which is a brilliant solution to be able to change that. Another was making washing machine bodies, and in these washing machine bodies, a process had to be done to all washing machine bodies. It was the same process, but there were 4 different sizes of panels that had to be used. And so the way that it was done is by having these rotating blocks, and each of these rotations would allow a different size panel to be in the right location. And then the process could happen at exactly the same place. So yet another really neat way to do it. two last ones here is one was a process that had to be set up, and there were 5 different positions that could be used depending on what part was being made. And originally when Shingo came, there were these limit switches. So a limit switch is an electronic switch, and when you click the little thing up here, it's for a table moving, you know, 2 things moving past each other, and when they hit and the limit switch engages, then that will stop motion, or it will let the machine know that it has achieved motion. And when he arrived, they had a rail, and it had 1 limit switch as part of it, and then they would take this limit switch, and each time they needed to change parts, they would adjust the limit switch to a different location, to any of these locations shown. And that took a little tweaking too. So they would adjust it to the location, and then they would have to run a part and see if it was right. And if it wasn't quite right, then they would tweak the position a little bit. Instead, the system that Shingo came up with was have 5 limit switches and have a method of only connecting one of them to the current. So these 4 are not connected, or you could connect them in parallel. So making any single one switch would cause the system to trigger. And you just engage that one switch, and now switch 5 is active, and all these other switches will get switched, but nothing will happen because they don't have current flowing through them. And then the last thing is that these ideas were very innovative and new when Shingo did them. But since then, many products have been developed that can help you to do single-minute exchange of dies, and so that you don't have to make things. So this yellow part out here is the bolster extension, so that you can come out and set the die onto these items. You could put them on both sides. This would allow you to roll the die off the back side and have the new die sitting on here ready, and it could roll into place. All kinds of different locks that lock things down very quickly. This also has these red things here, so those are ball bearings, and they're sitting in rubber in the T-slots, and so when you don't have the die clamped down, they will extend up and make it so that you can roll the die onto and off of the bolster, but then when you clamp them down with the clamps, they sink down into the rubber, and they don't get in your way, so that you can position things correctly. Okay, we're going to watch a short video now, and in this video we're going to look at just some interesting innovations. They're kind of lean, kind of single-minute exchange of die innovations in the Volkswagen plant in Germany. All right, so there's Richard Hammond.
Inside there are 6 huge pressing tools that are cutting and shaping panels at a phenomenal rate. So raw steel goes in that end, and then fully formed car body panels come out of that end. It's all powered by hydraulics, and it can exert an unimaginable 8,000 tons of pressure. So that's like having all the metal of the Eiffel Tower land on your head. It's so powerful that this shop had to be built on its own separate foundations. Otherwise, buildings on the other side of the factory complex would shake when it was working. And they don't just have 1 or 2 of these presses. There are 20 of them in this shop, like this. In total, the press shop makes 500,000 car parts a day. But of course, they can't just make 500,000 bonnets. They also need to make all the other parts. Oh, this is so manly! This is about as much as I've ever been. That means changing the huge pressing tools 6 times a day. And the man in charge of doing that is veteran car maker Klaus Wehrmann, who has over 30 years' experience across almost every department in this huge factory.
So first of all, you see them there setting the dies on the bolsters outside the machine. And so that is a place where they've taken IED and they've made it OED. So they are doing all of the alignment out here outside the machine where they're not under time pressure to do it, and the machine is still making parts in the background. And look, they've got a potted plant. How nice.
How much does that weigh?
It's nearly 25 to 30 tons here.
You don't want that on your foot.
No, that's not good.
So this is the pin that holds the top of the press to the bottom. But if you look around here, there's just a little column. And if you just lift that up and get it in the right place, it goes through. To be fair, I can't really mess this up. Then it's done. Gotcha.
So I think that's another really neat innovation right there. Rather than having to unscrew something off the end of those pins or even pull something off that's a separate piece, it just has that part that falls down, has a larger internal diameter, so it falls down. So gravity activates it to be in the safe position to keep the pin from coming out. But all you have to do is push that pin up a little bit. You can slide, or push the ring up a little bit. You can slide the pin out and take the strap off and then resecure it. Notice that they were resecuring it so that it stayed with the die, so that when they're ready to lift it again, they don't have to go find a set of pins. The pins stay with each one of those.
When you produce enough cars every year to create a tailback from New York to Las Vegas, they have to be shifted off-site as quickly as they're made. Hence 60 kilometers of track and the largest private rail station in Europe. But big infrastructure comes with its own problems. In the old days, freight leaving a factory might be loaded onto a train like this. A complete trainload of empty wagons would be shunted into place at dispatch. It's then loaded using ramps in between the wagons, means the first cars can drive the full length of the train and it can all be filled in one go. But bear in mind, when it's 20 wagons long before they can hook it all up and depart, it takes time. So quicker is important, and the answer to that is over here. It's a sliding stage, 3 wagons wide, and how it works is wonderfully simple. It moves sideways. Empty wagons can be shunted into empty bays. Cars can be loaded onto waiting wagons, and fully loaded wagons can be hooked up to waiting trains, all at the same time. It's fast and it's flexible, because each car only has to travel at most the length of one wagon. It is really, really clever. 10 train loads carrying 1,800 cars leave the factory every day. I wonder if I can help.
All right, so that's pretty cool in its ability to move cars around. You can see why that wasn't an obvious idea. You don't think of taking the train car and sliding it sideways and disconnecting all of the train, loading each car individually, and then putting it back together seems like it would be a very laborious task. But because of this sliding system, you can do it quite quickly. And so in a way it is single exchange of dies, because what they're doing is preloading those train cars so that what makes you money is shipping the cars off-site. Loading the cars on a train doesn't make money, but shipping them off-site means that they have gone to, been sent to the next area where they will be sold, or maybe they already are sold. And so it is the same concept as single minute exchange of dies. If you continue to watch that video, it's pretty cool too, because they were wasting too much time with the operators of the trains, the locomotives, having to go back and disconnect and connect train cars and then walk back to the locomotive. And so instead, they have a remote control, and all of those locomotives on site are remote controlled. And so they can bring the locomotive to them. They can go get train cars. If they need to get off and work on train cars, they can still advance the entire locomotive and all of its train cars forward to be able to deal with connecting the next one. And then at the end, they can get on it and drive off, and it requires fewer people. So amazing systems, good ideas in how to reduce the amount of people and time that it takes to ship product. All right, so in class we're going to do a project where we're going to take some fixtures and we're going to try to figure out how to optimize some processes, thinking about these 3 steps of the single minute exchange of dies methodology. Hope to see you there. Bye.